The Minecraft title screen. For 7 years, this was the panorama image that appeared. This was later changed in newer versions of the game, but for most of Minecraft's lifespan, this was the image you'd see every time you'd play Minecraft. But have you ever wondered what that image really is? Is it a real Minecraft world that you can generate? Well, let's not get too ahead of ourselves. Today, we have a lot to cover. Let's start with the history of the Minecraft title screen. In the early days, it wasn't anything too special. The background was just plain old dirt. But when Minecraft Beta 1.8 was released, the title screen was completely overhauled with a brand new moving panorama background. And it stuck. In fact, I'd say that it stuck around so long that almost every seasoned Minecraft player is certainly familiar with this particular title screen. And that's when a programmer by the name of Tom Latsko got the idea. After watching my video about the pack.png project, he got inspired to also try to find the actual seed of the title screen image. At first glance, it almost seemed impossible. This image is so blurry that there couldn't be any way to get any useful information out of it. However, by looking into the game's files, you'll find this: 6 images that make up the title screen panorama. Here we can see a lot more detail, as the game itself creates a blur overlay when shown on the title screen. With those image files, Tom started to do some research to see if the idea was viable. Now at first glance of the images, the terrain doesn't look like what you'd see in modern versions of Minecraft. If the seed was to be reverse engineered, it's crucial that it's known exactly which version of the game that this image was taken in. At first, this was a bit worrying, because between versions Beta 1.7 and 1.8, Notch was working on massive changes to the world generation system. If this image was taken sometime in between those versions, the chances of finding this image would be next to impossible, as the development versions of this world generator are pretty much non-existent. But luckily, this wasn't the case at all. It was as simple as taking a look at the image's metadata, which showed exactly when the image was saved: June 27th, 2011. Now this date is really important to know, as this was months before the Beta 1.8 pre-release was distributed, and even before Beta 1.7 was released. This pretty much confirms that the world generation system either had to be Beta 1.6 or Beta 1.7, as it was pretty much identical in both versions. Now that Tom knew that the project was viable, it was time to recruit the others and to start looking for clues. A recreation of the image also started to be constructed. One technique that was used to confirm block placements was a simple program that overlaid the recreation with the original image. This was extremely helpful with the process of brute forcing terrain near the end of the project. As that was taking place, a big push was starting to be made to try to find exact coordinates of where the image was taken. 2 things were used. First, similarly to the pack.png project, the clouds were used to find the Z direction. But what separates this the most from the pack.png project is the fact that the image contains tall grass. That's right, the tall grass in this image was crucial for finding the exact coordinates of where this image was taken. Let me show you why. If you take a close look at tall grass in Minecraft, you can see that it's not always placed in the exact center of a block. It appears to be randomly offset by a few pixels. What's interesting is that these offsets are exactly the same for each world seed at a given coordinate. So it's not even random at all. The team used that to their advantage. The Z and Y coordinates were already found by Tom earlier using the cloud patterns. This now made it possible for him to search the remaining X coordinates manually by placing tall grass in a single player world to hopefully find a match to what was seen in the image. And surely enough, it worked. This got him the exact coordinates of where this image was taken, which helped the whole team make reverse engineering the seed much easier. In that version of Minecraft where the panorama image was taken, there are 2 to the 48 different seeds that could exist, which is this number. That's just too many seeds to search through using terrain, so a good portion of them would certainly need to be ruled out. Earth Computer originally had the idea to use the trees to find chunk seeds, and then work from there to eventually find potential world seeds. However, that ended up not working out, and the team eventually realized that other aspects of the image would work better for reverse engineering the world seed. So one of the team members, Pseudogravity, looked a bit closer at the image and noticed how the colors of the tall grass were slightly different from each other. The reason for this has to do with the biome blending algorithm that was used in the game at the time. So pseudogravity took the color values and the coordinates of all the tall grass in the vicinity and graphed them, as seen in this image. This was used to then eliminate every possible seed that didn't have that exact combination. This reduced the amount of seeds from 2 to the 48 down to 2 to the 36.4. Then there was this border between the desert and plains biome. That information was also taken advantage of and reduced the amount of seeds down to 2 to the 23.5. At this point, enough seeds were ruled out to finally be able to brute force the terrain itself. This process usually takes a very long time, about 1,000 to 5,000 seeds per second on a typical CPU. So it was crucial that the seeds were reduced down to just a few million. Then it happened. They found the seed, and they were really lucky with this one too. After searching through only 12% of the remaining seeds, the exact one was found. Actually, it was 2. That was completely by chance, as some worlds have multiple valid seeds. So here we go. I have Minecraft 1.7 loaded up, and let's generate this seed. Now I just have to walk to the coordinates, and there it is! It's actually real! This is the actual world that is on the Minecraft title screen, and now anyone is able to play on that exact map. And it's all thanks to these people. Earth Computer, for creating a mod to replicate beta tallgrass offsets, and helped a lot with writing the final seed cracker. Cortex, for also helping write the seed and terrain cracker. Dutchin18, for writing the cube map mod used for the recreation overlay and helping reverse engineer and test tall grass climate values. Neil, for creating code that helped crack the terrain. Tom Latsko, for starting the project by finding the Minecraft version and coordinates, as well as making the recreation overlay website. Pseudogravity, for measuring the colors of the tall grass and for writing the program that reversed mapped the colors into ranges of possible climate values. There were many other great people that helped with the project, and the full list can be seen in the video description. I also want to thank the contributors to the Minecraft at Home project. A good portion of the processing power used for the project came from the volunteers that contributed their resources to Minecraft at Home. 54.5 exaflops of processing power ended up being used. And if you want to contribute some of your extra computing power to future projects that Minecraft at Home has to offer, like finding the tallest cactus or even the pack.png project, click the link below. They can use all the help we can get, so I'd go for it. For years, everyone who played Minecraft saw this image in the title screen. To be able to play the game in that same world, to many, was just a dream. But now, it's a reality. So go. Type in the seed, load that world, build your house, right in the same world as the Minecraft title screen.